All right, this is the second video. Left off on number 13, but I just wanted to point out in the last video for number 10, I said that the answer was A. I forgot that I was multiplying 1/2 by 1/2. This should be A over 4, not A. For number 13, we have n minus 4 divided by 9n plus 9, and we're taking away n minus 3. When we have the common denominator, I know that my answer is going to be divided by 9n plus 9. When we're subtracting, we need to make sure that we're changing the sign for both the n and the n minus 3. So this will be like if I was adding a negative n and adding 3. So it's like n minus 4 minus n plus 3. Adding and subtracting n are going to cancel. I'm left over with negative 4 plus 3. So this will be a negative 1 over 9n plus 9. At number 14, I've got two different denominators. B minus the 4 and b minus 3. So I'm going to multiply both of these by the least common denominator, which is b minus 4 times b minus 3. So this is going to look like 3b over b minus 4. And I'm going to multiply times b minus 3. 4 over b minus 3 times b minus 4 over b minus 4. So this is going to be 3b squared minus 9b plus 4b minus 16. All this over b minus 4 times b minus 3, or 3b squared minus 5b minus 16 over b minus 4 times b minus 3. All right, and number 15, I need a common denominator. I see it's m minus 5, m plus 6. I need to multiply by 4. So I can write this all over. Actually, wait, put the 4 first. So to the 2m over m minus 5, I'm going to multiply 2m over I'm going to multiply that by 4 times m plus 6. This is like 4 times 2m squared plus 12m. And I'm subtracting 5m over the 4 times m plus 6, and I'm multiplying by m minus 5. So minus 5m squared. Now, if it's 5m squared minus 25, and I'm subtracting, then it's minus 5m squared plus, 25m. So if I multiply these by 4, this is 8m squared plus 48m. I'm taking away 5m. 3m squared, and then it's 25 plus the 48, which is going to be 73m over 4 times m minus 5 times m plus 6. All right, so when we have what we talked about, like the complex fractions, like if it's a fraction divided by a fraction or adding or subtracting, we had two options. We could multiply by the least common denominator or multiply by the reciprocal. Some people say it's like keep, change, flip. You're gonna keep the original fraction. We're gonna change the multiplication to, sorry, the division to multiplication. And then we're gonna flip or multiply by the reciprocal for the fraction or the rational expression that we're dividing by. So 2 over 3x. This will be equal to 1 over x. In this example here, it gets a little bit more complicated when we're adding. So when I see the denominator 3 in the 16, in the same way here where I wanted to have a common denominator of the b minus 4 and the b minus 3, I want to do that with 3 and 16. So I'm going to multiply both the numerator and the denominator by 48. So a over 3 times 48, if I divide 48 by 3, this is going to be 16 times a. If I have 3 divided by 16 times 48, this is going to be 3, so I'm going to subtract 9. And then 4 times 48, 4 times 40 would be 160. And then 8 times 4 is going to be 32, so this looks like 192 divided by 16a minus 9. Over here, I think it'll be easier to do the multiplying by the reciprocal. So this is m minus 3 divided by m. And if I'm dividing by m minus 3 over m minus 2, I can multiply by the reciprocal of m minus 2 divided by m minus 3. Some people will multiply this out, but if I see an m minus 3 here and an m minus 3 here, they cancel. I'm left over with m minus 2 over m. Some people feel like they can cancel the m and the m. You'd have to be able to factor out an m from both of these terms here to be able to cancel it out. So our final answer is going to be m minus 2 over m. All right, so in this example, they've got the common denominator. This is 8 over x divided by x. For some people, it helps them to imagine that we got one fraction. And because we work a lot with like the reciprocal, imagining that if you're just dividing here, that it's some number or variable over 1. So 8 over x times 1 over x would be equal to 8 over x squared. Okay, I don't think I put this in on the review, but one of these is going to ask for long division. And then the second one's going to be synthetic division. So for the long division, 6x squared minus 11. So I'm dividing 6x squared by x, which is 6x. I'm then multiplying 6x times x minus 1 to get 6x squared minus 6x. And when I subtract, these cancel, and this becomes negative 11x plus 6x to get negative 5x plus 8. I bring down the 8, so for the plus 8, and now I divide negative 5x divided by x to get negative 5. I'm going to multiply negative 5 times x minus 1 to get negative 5x plus 5. When I subtract these, this would change this to a positive 5x, and it's like I'm subtracting 8 minus the 5 to get 3. So this is your remainder. If you ask me how I would write this final answer, it would look like 6x minus 5. If this is positive, plus 3 divided by x minus 1.